opportunity to go ahead and make a video. Now, I was going to make a regular video for this, but I think a live stream is probably more appropriate because anything could possibly happen. And I do believe maybe some things will happen. All right. So I've got a series of boards here. And what I want to do is, so some of these boards are good and some of them are bad. Let's go ahead and clean up this work environment a little bit. I'm still unpacking my stuff. So I noticed some really cool things when I was testing this board with my multimeter, and I want to take this opportunity to show you guys that it really is possible that using different modes on your multimeter might get you some really interesting results. So now I understand that this video is going to be watched way further down the road, but I just want to tell you guys that whatever you guys see right here with this multimeter, I can't completely understand it. There is some stuff going on between diode mode and continuity and ohms resistance, and maybe you guys can help me understand what is going on with this meter, because right now I'm a little confused. And just in case, I brought an oscilloscope and a signal generator, and we might try some injection into the circuit to figure out what is going on. All right, so let me go ahead and get my meter out. So for most of these tests, I have a Fluke 289 true RMS multimeter. It's a really nice meter, probably one of my favorite ones I've ever used. But I normally use continuity mode just like most Biomeds out there. But I figured some stuff out on diode mode, which kind of goes to prove the point about using different modes when you're troubleshooting your circuits and your boards, because you're going to get some different results. All right, so let me go ahead and adjust this camera a little bit. Sorry, guys. I'm a little bit out of frame here. I am doing this on a cell phone, whereas normally I have a webcam and a laptop and going live. But I'm going to do this with a cell phone up here. So let's see how this works out. Now, anything can happen. So trust me, guys, I have no clue why I'm getting these results. So I'm hoping maybe you guys can help me out with that, all right? So let me adjust the camera a little bit more so I can get you guys a better view. All right, we're square. Good. Let me go ahead and get this guy out of the way. All right, so I have my Allosun oscilloscope. I'll admit it is far from the best oscilloscope in the world, but for the price and the fact that it is portable, I love it. Works out good. So I have a FG100 DDS function generator. Now this guy here, it's just a simple, cheap, inexpensive function generator, but I can create square waves and I can create sine waves of various frequencies and different amplitudes. And we can inject that into the circuit between a known good board and defective boards, and we can help see what's going on. So I started doing some of this last week when I was at work, but I completely ran out of time. So here, let me just go ahead and plug my oscope in. We're going to save that guy for a minute because I'm going to save that guy so I can show you guys what's going on. All right, so I've got two defective boards. Yep, okay. So these boards here are for some Hospira pumps. These are infusion pumps. And what is known for happening is there is someplace on these boards a defective component, and what happens is it pops a tiny little fuse, F3, right here. You can see it. And right here is a battery connector, and I believe this one here is a motor connector. Now, guys, I've always said that when you have power in and power out, there's always going to be fuses, okay? So there's little round fuses right here. This is for the AC input. And you have your battery right here, to which I have an F4 fuse. So you guys can see that one right there, and F3. And F3 is normally the one that pops first. Interesting. So F4, I don't know if that one's for the battery. We could do a real quick continuity to check that. Doesn't even matter. But So this one here is my good board. And let's see, these two are bad. And a couple of these are really boogered. Okay, so this one here, you can't even tell it's bad. Well, I'll show you real quick with the multimeter how to find that. And let's see, and this guy, somebody took a botched job trying to solder on some fuses. Look at, you can tell really bad right there. Look at that solder job, guys. So anyway, I walked into this situation. You know, somebody else has been obviously trying to troubleshoot these boards. So let's go ahead and do what we normally do. Let's start this multimeter and let's put it on continuity mode. All right, here, I'm going to get this meter so that the camera can see it well enough. Okay, hopefully it's all in frame. Right, I'm going to invert the multimeter so that you guys can see it, because on continuity mode, I do not have to see nothing, all right? The component level troubleshooting, you betcha we're going to do some of that. You got to understand what's going on with your boards. Other words, you're not going to be a very good troubleshooter. So just with the knowledge that there are always fuses by power inputs on PCBs, almost always. There's either fuse links or there's going to be fuses of some sort. They always put a weak link in. Sometimes it's a tiny little resistor, like a 0 ohm resistor, still acts like a fuse. But just be aware that anytime you have power in and power out, anytime you have battery connectors on a PCB, you're definitely going to have some sort of fuse there in the vicinity. So let's go ahead and take a look. Here, let me be sure I turn on continuity mode. There we go. Okay, you guys can hear that? We're good. So let's go with F4 on the botched board. Okay, well, even though it's got a horrible solder joint and it looks like it's got some cold joints on there, it's obviously got contact. We don't know how many amps that can handle, but hey, it's got contact. So let's try F3. And you can tell F3 is bad. Okay, so we know that F3 is bad on this board. Let's check this board real quick. I'll orient it just the same so that you guys can stay with me. F3 popped. F4. So you can see a trend here. F4 is good and F3 is the one that's been popping. All right, so let's try this one real quick. F4. Okay, so on this one here, this is going to be our control, and we're going to use a known good board to find what's going on with these boards, all right? And this is where it gets really interesting. So now we're here. Let's go ahead and shut that off. We're going to put it on ohms. And let's see if I raise it up. Will you guys see it better? Yeah, you guys can see it. Okay, so let's go ahead and check the ohms of this little guy right here. So you guys should be aware of is boards are all separated in different regions. So when you see large capacitors and stuff like that, this is going to be your power supply side, okay? And you're going to have your rectifying diodes here. I could label all the stuff that's on here. Doesn't really matter. What you should know is that the board is pretty much divided right here. And it's got a little bit of a division over here, right here along this line. And there's some components that kind of give that away. Like right here, this tiny little resistor. Oh, let's see if I can get closer to you. So you can see this, there's a cap and a resistor right up here. And this right here looks like another plane of the board. So right here is the battery. I don't know if this is the battery charge controller. That looks like a voltage regulator right there, which might actually matter if you're charging the battery. So I'm just guessing because I have not looked up any of this yet. But what I can tell you is right here, this looks like a plane of the board. We've got a coupling capacitor, it looks like right here. And what we're going to pay attention to is this, there's a resistor and a cap right there. So these two right here are going to give some really interesting results. So I'm going to go ahead and I'm going to lower this camera down way closer so that you guys can see right up close. And I'm going to try and keep the multimeter in frame, okay? So bear with me, guys. Oh, actually, heck yeah. I've got another tripod here. Just a moment. I've wanted to make this video for a little while now because I think it's going to have some real cool results. And let's see, is that going to be low enough? All right, how about this? I've got it already on a tripod. And, oh, whoa, of course it's going to flip over. Why wouldn't it? All right, not low enough. Sorry guys, if the camera's moving around quite a bit, that is what you get when we are doing this live. Okay, well, you can see the meter and you can see where we are going to be testing. Okay, so this right here is the good board, all right? So we are on resistance. Okay, here is that resistor where I was telling you it kind of sections off the board. So let's go ahead and take a resistance measurement on this tiny little resistor. Okay, 9.46 kilo ohms. Okay, you got that? And the little capacitor over here, we will go ahead and we'll play around with that guy in diode mode. You can see that it actually is discharging right there, probably because of the polarity of my leads. Anyway, right here we got 9.9 something. It doesn't really matter the details. So I'm going to go ahead and switch my multimeter over to diode mode. So here is where the magic happens, guys. So let's switch it over to diode mode. Okay. And on this meter here, I have to go to menu, diode. There we go. Okay, so diode mode puts out a select amount of voltage on the leads, and they are polarized, so it does matter left or right. But let's go ahead and check that little resistor, and let's see what happens when we put it on diode mode. So notice on the multimeter, see how it says 2.52? That is volts that it is dropping across this little resistor, all right? So that's pretty important for what we're going to see on the bad boards. So right there, 2.52, it's very constant. So I know that that resistor is good, but the circuit around the resistor is also going to be an issue. Okay, so now let's go ahead and let's go over to one of the bad boards, all right? So let's go ahead and put it back. We're going to do menu, run ohms, we're good. Okay, so here we are on one of the bad boards. We're going to check that same resistor. You can see it's 9.9 something ohms. That's interesting. That means normally you would think that that resistor is good, and it is. It is good, by the way. But let's go ahead and switch it over to diode mode. And let me make sure that I keep the polarity of the leads correct. And let's go to menu, diode. Okay, so now let's check the voltage across that same resistor. Do you see that? So I have resistance across that resistor, the exact same as the good boards, but now take a look. It is saying OL on diode mode. Now I'll go ahead and switch the leads around just in case. Shouldn't really matter on this particular test. But so you can see, no matter how I do it, this particular resistor right here, I am showing OL, which normally, I don't know, guys. This is where I need, and it's very constant. So let's go ahead and take this is the other bad board. So let's go ahead and go across the same resistor on this other bad board. Look at that. OL. So whatever is creating voltage drop condition. And the only thing I can think of is that someplace it is shorted between one side of the resistor and the other side. There's a dead short. And you know, electricity always takes the path of least resistance. So instead of going through the resistor between two probes and thus measure the voltage drop, it is actually, I think, no, it's not open. Resistor's got resistance. This is what I don't understand, guys. What is going on with that little guy? And the only reason I'm picking on him is because it does seem to segment the board right about here. All right. And since it's segmenting the board, I usually go to those common components That way there I can section off this side of the board or that side of the board, but I don't understand what is going on with that little resistor. What could possibly be creating this condition where on a good board, I have a voltage drop of 2.52 volts. I don't really get it. Let's see. Where's my large resistor? I got some known resistors around here, and I'll show you guys what I would anticipate, what I would expect. Oh yeah, look at this. Okay. So here, this, I know it's kind of large. This is a 10 ohm, and this is what, a 250 watt resistor, but it's still only 10 ohms. So let's go ahead and see what it gets when I drop across. So there you go. You can see that I've got 0.0102 volts. It's only 10 ohms. It's really low. So what is going on with these guys? I'm really curious. I'm going to go ahead and raise the camera back up now, but you can see kind of what I'm going for. The board is kind of segmented right here. And the reason that I'm going and I'm attacking these boards so well, guys, the reason that I'm attacking these Hospira pump boards is because they're all breaking in the exact same manner. So once we figure out what the bad component is, we can change out that component. Instead of buying these boards over and over and over again, we can just solve the problem. So I'm pretty sure that there is something very specific that is popped or shorted. I just don't get it. And I'm starting to think it's probably one of the IC chips. I'm not really sure. I did check the voltage regulator and it did look like it's perfectly fine. You can test that in diode mode just the same. So here is what I am going to do. Let me go ahead and adjust this camera down a little bit. There we go. Okay. So I've got my oscilloscope here. I've got this is the good board, this is the bad board, and I've created a little jig. So here is the battery clip that will inject voltage into the good board. Oh, let's do it to the bad board. Let's just start there, and let's not have the botched board because somebody took a turn at soldering. Okay, so here is my function generator. And what I'm going to do is I'm going to inject a pulsed wave into the battery port and try and figure out where it's stopping or where it's attenuating. So, I mean, someplace I assume there is a shorted component, and because of that, that is why it's popping the fuse. Now, remember, fuses will pop because of an overcurrent situation, which is almost always a short. Okay, so let's see. Can you guys see? All right, so let's see. It's sine wave. Let's go ahead and change it. Square wave. I definitely want to do a square wave. And let's say 100 hertz. So let's go ahead and take it down. 100 hertz. Run. Okay, so right now I am injecting 100 hertz square wave into the battery port. Now I could inject straight voltage into it, but that would not be good because it's really difficult to test straight voltage when you're trying to track back through a board. So by doing a pulsed wave, I can actually go through the components and see where it's getting less and less. So let's go ahead and set this multimeter over the side. Let's pull up the oscilloscope. All right, I hope I can still get all this on frame for you guys. Now, mind you, this is new territory to me. So unlike what you guys might be thinking, this type of troubleshooting is definitely new to me. It is a theory, and I'm going to go with it. I'm just going to see what we get. Come on, turn on. Okay. Let's see. I think you guys can see the oscilloscope. Maybe not so well. I have to be able to read it, though. So let's go to F3 and let's see. Okay, I have a pulse on F3 and it looks like it has a negative bias. Oh. Negative bias means that the square wave is actually sitting low, below the 0 volts. So let's go ahead and let's shut off channel B. let's disable channel B. Okay, menu. Okay, and we're gonna hit auto. I know some of you guys don't like auto on oscilloscopes, but every once in a while it makes life easier. Okay, well you can't see, I can see the line wavering up and down, and auto is not really doing anything. So let's go ahead and, okay, and let's lengthen it out a little bit. Okay, and let's actually bring it a little bit larger. Okay, so you can see the negative bias right there. See how it goes low? And I have a sawtooth, and it's pretty plain sawtooth too. I do wish I had a better oscilloscope for you guys so that I could show you guys up close. So that is on F3. That's the fuse that normally pops. So let's go over to that resistor. Let's go millivolts. Let's bring it in a little bit bigger. Okay, nanoseconds. And there we go. So you can see the oscilloscope is doing some crazy stuff. Let me check just to be sure. Hold on, I gotta check. I'm changing my ground. Sorry guys. Let's do auto. Okay, so my meter is triggering and it's showing square wave. So I really wish I had a better oscilloscope. Let's bring this guy up a little bit. Okay, so what I'm doing is I'm changing the voltage division there. You can see my square wave. Hopefully you guys can see it. Let's see. Does that help? No, not really. Come on. About that. Now you guys can see it. All right, I was thinking the light was going to affect the camera. Okay, so I have my square wave here. I'm clipped onto my negative terminal. So let's go ahead and check that resistor. Okay, so I have a same pulse. Okay, I'm on the other side of the resistor. Okay, so I think it's going to be one of these ICs that is shorted. Well, this is going to be interesting because I am getting on almost every single pin of this IC. I'm going to have to look up the data sheet. So I assume that this leg right here is attached to the ground plane because it's reading 0. But every other leg is showing me the square wave, which I don't think that that's right. Okay, so let's go ahead and unplug this guy. Okay, that's the bad one. This is the good one. So let's go ahead and see if I see the same thing on the legs of the good one. Square wave, square wave. Okay. All right. Okay. All right, so I am seeing the same thing on this guy. Let's go back to our bad board. Sorry if I'm flip-flopping, guys, but this is how you're going to have to troubleshoot if you don't have any schematics and you don't have the data sheets for all the components. This is it. Oh, shoot. This is the one with the botched soldering job. I'm just going to place that guy out of the way. All right, here's the one that hasn't been tampered with yet. Okay, so let's see. Let's go over on these ones. Okay. So I'm going right around the port, and I'm checking some of the components that are around the port because that's where it's popping the fuse. Let's see, we got these little transistors here. Okay, so one leg of that guy is on the ground. Okay, so that transistor's off. Ground. Ooh, wait a minute. Okay. So this one here from, well, I don't know which type of transistor this guy, if it's a NPN or NP. So this one here between what is the base and the collector, maybe. It appears to be shorted. So let's go back to the good board and let's see if it's the same way on this guy. Okay. Square wave. Square wave. Ooh. Wait a minute, that's interesting. Okay. So this guy here, it's here, let's go ahead and zoom in a little bit for you guys. So here's my 0 line, and you can see where the base is just below the 0 line. So it looks like it's positive about, I don't know, 8 or so volts. But when I go over to what I think is the collector, you can see that it's actually inverted, and now the square wave is negative. See that? So this is the good board. Okay, so there's definitely some change on the wave. Put this guy back in to the top. Okay, so that one's the same. Good. That is so interesting. So I got nothing. I got nothing. And this one here's got the square wave. Square wave. All right, guys. Well, I think I'm going to proceed with troubleshooting it like this for a while and start writing down some of my results. Okay, so these ones here all have the square wave. All right. Well, guys, I'm really a little baffled about this guy. So I did check without removing any components, the 2 diodes right here near the voltage output for the DC power supply section, and everything seems to be pretty normal over there. It really does. So what I'm trying to find is a spot where the wave is dramatically different between the good board and this bad board. I mean, it would be dramatically different too. It would be probably shorted, I'd assume. So it's one of these spots where I'm receiving a flat line. Okay. Now all my capacitors look like they're in excellent condition. I haven't tested them yet, but they look like they're in really good condition. So I'm a little confused about that. Anyway, guys, I'm really curious about this. I know the problem is right over here. I know it. I'm going to go ahead and shut this guy off. And let's go ahead and bring this guy back. So let's see. I am in diode mode right now. I think there. Now it's in frame. Right? Yeah. So let's go across that same resistor again in hindsight to show you guys. Okay, so this one here is showing OL, which is the same thing as it being open. And the good board is showing 2.51 volts. You see that? So I'm just kind of amazed because they both have the same resistance. It's 9.9 kilo ohms is that one resistor. So, but that's with it in the circuit, by the way. So I'm really kind of confused about this guy. Now I'm going to continue on with the voltage injection, and I'm going to see someplace here I've got a component where I probably have it shorted. So if I'm injecting a square wave into this, I'll probably inject into the pin next, but it's almost the same circuit. So I'm really curious what the heck is going on with this guy. So I'm really interested in what is going on with this. Why is it that one has a drop on diode mode and the other does not? The bad board does not. And it doesn't beepity beep like if it's a dead short. So that would mean that it's open. But how could it be open if the resistor is measuring correctly? But the resistor is in the circuit. So what if, I don't know, that doesn't make any sense. Guys, I'm really confused about this. Now, what I could do is take a soldering iron and lift that resistor completely out of the circuit and measure it. Probably would be the next best step. But I think I'm going to continue on. I really don't know what else is going on with it. I'm really curious, guys. What do you guys think? What could cause this kind of situation? Now, I tried drawing it up as a schematic already, just to kind of put myself in the right frame of mind for what's going on with the circuit. And I just can't think of a situation where it would appear that it is open for diode, but at the same time, it's still got resistance. Now, the only thing I could think of is in diode mode, you know, there is no current if the polarity is wrong. Now, you guys should know that. But the thing is, I can switch the polarity of these two bad boys, and it appears open. I switch them this way, and it appears like it's open. So, what the heck is going on there? 2.51. Let's invert the probes. Okay. So in one direction, like I said, polarity matters. And in one direction, I have OL. So there's a diode someplace that is stopping the flow of electricity between the two probes. And then I invert them, and now I'm measuring across that resistor. Wild. What could be causing this? So polarity does matter on the good board, and on the bad board, I'm not getting any readings whatsoever on diode mode. Anyway, go ahead and leave your suggestions in the comments. I'm going to go ahead and read through them, and I'm probably going to revisit this because I've got all the equipment set up here. I'm too curious. These Hospira pumps, whatever component is going bad, it's going bad on all of them. And they're all identical. So that's why I really want to figure it out. Maybe I'll get some shots up close with the microscope so you guys can see the components and the layout real close so that you can see what I'm working with. Maybe I'll even label on the image what component is doing what in what condition. And maybe I can get some input from you guys that way. That's probably a better way to do this, isn't it? Anyway, guys, this is one of those projects where maybe I can get some help from the community. Some of y'all are way smarter than I am. I'm just trying to maybe figure out what's going on with these boards so I can release it to the community. There are a lot of the Plum A Hospira pumps out there. So I'm just trying to figure this out so that maybe I can show you guys how to repair this board and we can press forward as a community and get these guys repaired instead of buying replacements all the time. E-waste is a problem, and I do support people repairing their stuff. This, although it is surface mount, it's probably not that complex. I have changed out those fuses and stuff like that in a crowded area like this before. Just got to be wary of your plastic on your Molex connectors and stuff. I've got some special tape that I'll put in and around those, sometimes aluminum foil, so that when I'm heating up the area with a hot air gun, that I keep the heat off these components right here. But anyway, guys, I'll be looking forward to you guys' suggestions in the comments down below, and maybe I'll come back and do a formal video showing what I found, and maybe I'll be trying some of you guys' suggestions live on the air, because this would be such a cool way to troubleshoot going forward, is if you guys could help technicians in the field. Just curious. Let's see how well this works. Anyway, guys, thank you very much for your time, and I will definitely be looking forward to your suggestions.